In this video, we are going to learn how to round values correctly. Oftentimes, we perform calculations using measured values, and we rely on calculators to do the math for us. However, calculators do not understand significant figures. Calculators are designed to display as many digits as possible on the screen, and when they run out of space, they simply round the last digit. Calculators are also very literal about the order of operations. This means we must be careful when entering calculations so that we clearly communicate what should be grouped together, what should be subtracted, and what belongs in the denominator of a fraction. Otherwise, the calculator may perform a different calculation than the one we intended. If you need help learning how to use the TI-36X Pro scientific calculator, you can check out a separate YouTube playlist I have dedicated to calculator skills. When rounding numbers such as 1.23459999, the first thing we must know is how many significant figures are required. Suppose we need 3 significant figures. We begin by counting the first 3 significant digits, which gives us 1.23. Then we look 1 digit to the right, which in this case is a 4. Because 4 is less than 5, we round down. Rounding down means that the last retained digit stays the same because the other digits became 0. We then write the result as 1.23. Now consider a slightly different number, 1.2351999. Again, we want 3 significant figures. We count 1.23 and look at the next digit, which is a 5. Digits of 5, 6, 7, 8, or 9 indicate rounding up. When we round up, the last retained digit increases by 1. This changes the value from 1.23 to 1.24. It is important to always perform calculations using full calculator precision first. Rounding should only be done once at the very end when reporting the final answer. Let's look at another example. Suppose we are asked to round 3,981 joules to 2 significant figures. We begin counting from the left. The first 2 significant digits are 3 and 9. We then look 1 digit to the right, which is an 8. Since 8 is greater than 5, we round up. The 8 causes a carry into the 9, turning it into a 10, which then carries again to the thousands place. The result is a 4 in the thousands place and a 0 in the hundreds place. We must then add zeros to preserve the magnitude of the number, giving 4,000. However, writing 4,000 creates ambiguity about how many significant figures are intended. We need 1 0 to be significant, but not the other trailing zeros. To clearly show 2 significant figures, we write the result in scientific notation as 4.0 times 10 to the third joules, or equivalently as 4.0 kilojoules. Now let's practice rounding using both counting significant figures and decimal place rules. First, round 17.22 to 3 significant figures. The first 3 significant digits are 17.7. The next digit is a 2, which is less than 5, so we round down. The final result is 17.7. Next, we round 9.66 to 2 significant figures. We keep 9.6 and look at the next digit, which is a 6. Because 6 is greater than 5, we round up. The result is 9.7. Next, round 151 to 2 significant figures. The first 2 digits are 1 and 5. To preserve the place value, we must include a trailing 0, giving us 150. To avoid ambiguity, this value can also be written in scientific notation as 1.5 times 10 squared. Next, round 69.995 to 3 significant figures. The first 3 digits are 69.9. The next digit is a 9, which causes rounding up. This rounding up produces multiple carryovers, ultimately resulting in 70. The decimal point is necessary to communicate that this value has 3 significant figures. Next, round 15,289 to the hundredths place. The hundredths place is the 2. The next digit is an 8, so we round up. The result is 15,300. This can also be written in scientific notation as 1.53 times 10 to the 4. Notice that we do not include a decimal point in the standard form because we do not want the trailing zeros to be counted as significant. Next, round 2,899 to the tens place. The tens digit is 9, and the ones digit is also 9, so rounding up causes multiple carryovers. The result is 2,900. To clearly show that the 0 in the tens place is significant, but the 0 in the ones place is not, we write the result as 2.90 times 10 to the 3. Next, round 3.449 to the tenths place. The tenths digit is the first 4, and the next digit is also a 4. Because this is less than 5, we round down. The result is 3.4. Finally, round 69.995 to the ones place. The ones digit is a 9, and the next digit is also a 9. So rounding up results in 70. To show that the 0 in the ones place is significant, we write the answer as 70 point with a decimal point. In scientific notation, this would be written as 7.0 times 10 to the first. We do not include additional zeros because that would imply extra significant figures.